Hi, this is Dr. Lore from Ever Biotechnology. I will be demonstrating fully automated tissue microarray AutoTiss 10C in this demonstration. Hi, this machine comes with high-resolution camera over there, and there's also a light underneath for taking slide image. And we also have thickness detector for measuring the thickness of the blocks. And there's the barcode reader as an option. The machine has this rotator, and you can take up to 9 donor blocks from here to here, and also one recipient block which comes at this position. And there's a collector. This collector is for storing the recipient waste. And here I'm going to insert the recipient block, doing that. And then we can also use our special PCR block. PCR blocks can take the tissues from the donor blocks, and then you can use it for the PCR. Now I'm going to demonstrate the controlling system. This is the welcome page, and we are going to key in the user ID. Or you can come here and go to the administrator and create your own account. There. Okay, so that's enter. And the machine will start from calibration. So once the machine finishes its calibration, then let's open the cover, and then we go to the next step. And from the list, this is the donor block, and this is the recipient block. And we are going to load the donor from the list to the holder's position until 9. And where we can find the donor list, we are going to use the Excel file. You can see this is the Excel file for the list, and it's under the account folder. Okay, so we are going to insert a few blocks. So I have one more block to insert, and let's pick P6 for the third, and we are going to insert the block. And we also need to insert the recipient block. And after that, the system will measure its thickness. So we measure all. Okay, the purpose for measuring the thickness for each block is to make sure that all the donor blocks, once they are inserted, it will go all on the same surface. Some thickness, some donor might be thinner than others, and that will make them uneven. So that's why we need to measure the thickness first. So let's go to the next step. And then we are going to take image for each block. So that's the recipient block, the image for the first one, second, and third. As you can see, as for the first one, we use white dots. So that's one of the purposes of the machine is to identify where the position is. So we use the white spot to indicate the position of the tissue. And this one, it doesn't have that. So we have two options. One is to use the slide from the scanner, and otherwise we are going to take the image from the slide. So let's do that in the next step. And the second one, we can scan the slide. So we are going to place it right at the center of the rotator. And then we are going to have another one. So this is the slide for the third block. Okay, once we have done this step, we are going to the next step. It's the editor. So we are going to design the matrix. We can easily drag the corners, and then it will change the number of columns and the number of rows accordingly. And we can also change the gap. For example, 1.0, and as you can see that the gap increase. And we can also define the numbers of rows and columns. Okay. So the number of chords that you can insert, well, it all depends on the space. If we change the chord size to 0.6, and then change it to gap, change it to the 0.5. Then for this block, we can have as many as 16 by 26. Okay. And the puncher we are using right now is 1.0, so we want to change it. And then just for the purpose of the demonstration, we are going to just focus on the center. So we create a matrix. Now we can pick donor. So as for the first block, we can easily identify them. Then we just click here, and then select and assign. Okay, the second one, select and assign. And then assign. We also have this magnified image, so we can easily change it. Assign. Okay, then let's pick the second donor. The second donor has the slide image. Okay. So we have this opacity overlap, and then we can stretch it, can tilt, rotate, in order to align the image of this slide with the block's image. Okay. Or we can also use the slide image from the scanner by loading slide image. So open it. So as you can see that there's a contour in red color. So these annotations comes from the aerial viewer. So I'm going to demonstrate how to do that. Okay. So I'm going to change it. Choose this part. So I'm going to draw a contour here. and then save it. I'm going to load it again. So as you can see, that the image has been updated. And then once we finish the assigning the position, then we can start. We can choose to process the entire drawing and inserting the tissues by one action, or we can do it the drawing all at once and then do the insert later on. We will do it one by one. So let's start. So now the puncher is drilling. And now it's taking the tissue from the donor block. And move it to the position that we just drill. And it's going to push it in. The advantage of using our machine is to use this technology of coaxial punchers. It will take the upper two for drilling the recipient block, and then the bottom two for taking the tissues. So by doing so, we can make sure that they all align to the same positions. So unlike others that use two sets of punchers, and the disadvantage of using two punchers is that it has a misalignment issue. Okay, we just finished the processing. Then we can go back to the editor. Okay, for example, we can go to donor 1 and see how it drills. So we are going to take the image again. So as you can see, that they all drill according to the position we just assigned. And then you can also save the image. So the users can use this as a reference in the future. Then we can also export. So it has this information and details, including the position, the donor block ID, the layout, and also the setting. User wish to continue the process, maybe on another day, that they can import the file. This machine can take 9 blocks at a time, but if the recipient block needs more than 9 blocks, then we can do that starting all over from the beginning. Then we can use another 9 blocks, and then the user may continue doing so till they finish their recipient block. So the machine will calibrate again, and then it will jump to the to this page where you can load other donor blocks, ready for you to use new blocks. So we are going to remove them. Then we are ready to use new blocks and then insert. And then we will just continue this process. Okay. And then, as you can see, the collector bin just collect the waste from the recipient block. And this is the result by using 2.0 core sizes. The system can also create a template file. So the purpose of using the template file is that you can use this layout. Then you just the targeting donor over here in any way you want. And then you can use this template file over and over again to create different blocks using the same position, the same number of column, and same number of rows. And if the user wish to change the position of the donor, for example, if they dislike the donor position they pick, they can also pick another position and then rework. For example, this one. Then we can assign again. So as you can see that it's been assigned with a new one. For example, this one, and assign. So this one disappear and change it to this one. And the system will draw out the old tissue from the recipient block and then insert it with the new tissue from the same block. And one more thing worth mentioning is that the rotator has the heater underneath, and it helps to soften the recipient blocks and the donor blocks. And I guess that this will be the end of our demonstration.